Hello everybody and welcome back once again to Advanced Functions. We're still doing chapter 2. However, today we're focusing primarily on chapter 2.4, which focuses on families of polynomial equations. Essentially, this whole chapter just revolves around the equation for determining a family of polynomial functions. That's why it's the only topic that we're essentially going to be covering. So, what are families of polynomial functions? Well, first of all, a family of functions is a set of functions that have the same characteristics. Polynomial functions with the same zeros are said to belong to the same family. The graphs of polynomial functions that belong to the same family have the same x-intercepts, but will have or may have different y-intercepts. Unless 0 is one of the x-intercepts. An equation for the family of polynomial functions with zeros a1, a2, and so on all the way until an is written as follows. Y is equals to k times x minus a1 times x minus a2, again and so on and so forth until we get the binomial x minus an, where k is an element of all real numbers and k doesn't equal to 0. So for example, to identify a polynomial family of polynomial functions, you could have something as below. We have the following roots, or the following zeros. We have 3/2, -2, and then 1/3 as our roots. Those are the same in all of these examples. They might be in a different order, but they are still the same zeros. And then we have different k values. As you can see, none of them are 0, and also none of them repeat, which means these are all different functions of the same family. This chapter is genuinely extremely short. It just focuses on letting you learn about how a family behaves and whether or not you could determine the fact that something is part of a family or makes a function part of a family, which is exactly what we're going to do in these examples. The example asks us to find an equation for a family with the following characteristics. The zeros are -4, 3, and 5, and they also pass through the point 360. The steps for this are kind of easy. If we wanted to find the family, we would just do k times x minus -4, which is +4, x minus 3, and x minus 5. That's our family. Then, to find the particular equation which satisfies this portion, what we would do is plug in the x and y values. So now we have 360 is equals to k times 0 minus 4, 8 minus -4 times 8 minus 3 times 8 minus 5, and then we would solve for k. And that's all we have to do. Another important thing is that a polynomial function could have irrational zeros, which could be written as the following. For example, find an equation for a family where the zeros are plus minus 2 and 1 plus minus square root of 3. And it also has, the particular graph we're looking at has a y-intercept of -24. The steps at first are the same. You plug in the zeros into the equation y is equals to k x minus a all the way to x minus an. Now, what you need to do is remember that a factor of the equation is written as x minus a n, or a1, whatever you want to say. Since we have things like 1 plus minus square root of 3, what we're actually doing is having x minus 1 plus square root of 3 and x minus 1 minus square root of 3, which would give us x minus 1 minus square root of 3 and x minus 1 plus square root of 3 respectively. With that in mind, what you could do is now again plug in the x and y values and solve for k. Also, if you're reverse engineering this, you have to remember the difference of squares theorem, because that's going to be extremely important to this part. For example, we have x minus 2 times x plus 2. As we know, that's a difference of squares, so it's actually x squared minus 4. And that's all you have to know for this chapter. The questions are questions 2, 3, 7, 9, 10, 12, and 19 for chapter 2.4. Again, I will look over them, but I'm not going to explicitly solve them for you because they all test the exact same skill, which we just did in the example. If something appears as a little bit different, I will solve it for you. So let's do that in the next couple of moments. Okay, so let's first of all look at example 2, or question number 2. Examine the following functions. Which function does not belong to the same family? As we learned, a family has the same x-intercepts. So the first one has x-intercepts of -4, 5, and 2. Here have 2, 5, and -4, so that's good. Here have 2, -4, and then 2 again. That is the one that stands out since it doesn't have the same roots. Therefore, it is the one that doesn't belong to the family. 3, I think, was also assigned. Yes, it was. Let's highlight it. The graphs of 4 polynomial functions are given. Which graphs represent functions that belong to the same family, and explain. Again, we're just looking at the roots. So we have here -2, 1, 3. -2, 1, 3. That's good. -2, 2, and 3. This one doesn't fit in, which means that the ones that are in the same family are A, B, and D. D also has -2, 1, and 3. That's how we know. We just look at the x-intercepts for the zeros. Question 4 asks the same question, so I didn't assign it. So let's look at question 7. Determine an equation for the family of cubic functions with zeros -4, 0, and 2. Okay, so we're just substituting these values into the equation I taught you. B, write the equations for 2 functions that belong to this family. Now we just choose a random k value, and now we're happy. Determine an equation that passes for the member of the family whose graph passes through the point -2 and 4. Okay, now as we did in the example, we substitute the x and y values, and then we solve for k, and then it's asking us to sketch the graphs of parts of the functions in part B and part C. All you're doing is applying knowledges from chapter 1. So you're gonna plot your zeros. We're gonna plot the point that we know here, for example, -2 and 4. We know that these are all order 1, so they all just pass straight through, no bounces, no squiggles, and that's all you're gonna do. You don't know how high things will go currently because you haven't learned calculus, but that shouldn't be a big factor. I don't think your teachers are gonna look for that. For question 9, it's asking us to determine an equation for the family of a quartic function with the following zeros. So it's the same exact question that we had. Again, just apply that knowledge. So for question 10, now we have fractions. What you need to remember about fractions is that we often need to rewrite them. For example, we wouldn't write x minus -5/2. What we would do is first of all rewrite it as x plus 5/2, and then we would multiply both sides by 2, so we get 2x plus 5 as our factor. That's around it. That's a little bit different. Again, the rest are just applying the knowledge I just taught you. I also assigned 12 and 19, which is not here. Determine an equation in simplified form for the family of quartic functions with zeros 3, order 2, and the following. So what you're doing is following the example I showed you last time. But now since we have a order 2, what we actually have is x minus 3, right? And that whole thing's to the power of 2. Then we have x plus 4 minus square root of 3 times x plus 4 minus square root of 3 times k is equals to y. That is it. What it's also asking us is to simplify it, which would mean we just factor it or expand it and then try to find common factors to simplify it once more. For example, the negative 4 plus 3 and negative 4 minus the square root of 3. Again, that's the difference of squares. So you could have x minus 4 squared plus 3 as one factor, and then it would be x minus 3 to the power of 2, and then you simplify once more. Last one we have is question 19. The graph represents a section of the track of a roller coaster. Write an example for the family of functions that models the section of the track. Okay, so here, what do we know? We know that our zeros are 0, 30, 60, 90, 120, and 150. So we would have y is equals to k, x minus 0, so x minus 30, x minus 60, x minus 90, x minus 120, and x minus 150. Now we could substitute in a point to solve for k. So k, we would, let's see, what's a good point that we have? It seems like, well, these are close. So let's say 10, 12, or this would be 14, yeah, 12. 12 is equals to 10 times 10 minus 10 minus 20, and so on and so forth, and then it would solve for k. And that will give us the equation for that member of the family. That's about it for this part of the homework. Again, as you could see, today's homework or today's lesson was actually the shortest one we have to date. That's because, quite honestly, this chapter is so simple, but it's just important for you to realize that you could write different polynomial equations of different forms. So this chapter is just a little bit of a checkpoint and a relaxation break. Not many of the questions are difficult. You just have to remember how to deal with things that include rationals. If you remember how to do that, then you're more than good for this chapter. Tomorrow, or yeah, probably tomorrow, we have chapter 2.5 and 2.6. Chapter 2.5 involves graphing polynomial functions with a graphing calculator only, and chapter 2.6 is graphing or solving factorable polynomial equations with inequalities. So we're going to go over what inequalities are and 2 different ways to solve them in one single lesson, because again, for 2.5 it's a little bit difficult to explain it online since you'll be using graphing calculators in school rather than Desmos, which I'll be personally using to illustrate what you're doing to solve an inequality. But yeah, that is the lesson for tomorrow. For today, if you had any questions or are a little bit unsure about something, again, feel free to contact me. I'll be more than happy to help. I have thought about it, and I'm also not going to be covering any of the thinking assignments that are personally done in school for advanced functions and calculus. The reason for that is they usually change, and also I think those might be changed because of the curriculum changes coming in September with virtual school or mixed classes. If that does happen, I'm not really sure the format of those evaluations and what those would include. For that reason, I will try to stay away from them unless some of you contact me, particularly to talk about those topics. But other than that, I hope you've learned a lot today. Thank you for listening, and I hope you have a wonderful time.